There's a liquid that costs $2, not a premium coolant service, not a dealership package, not a branded bottle sitting on a shelf for $40, just $2, and with a single application poured directly into your existing coolant. In under 5 minutes, it begins protecting your entire engine cooling system from the inside out, stopping the kind of internal corrosion that slowly destroys aluminum engines over time, not for a short period, not until the next service interval, but in a way that continues working far beyond what most drivers ever expect from something so simple. This same compound has been quietly used by experienced mechanics in Japan since the 1970s, becoming one of the hidden reasons why engines there consistently reach 300,000 miles without internal corrosion issues, while identical engines in other parts of the world start developing coolant leaks, failing head gaskets and worn water pumps at just 80,000 miles, even though they come from the same production lines, use the same materials, and follow the same engineering designs, with the only meaningful difference being the presence or absence of this overlooked liquid that costs almost nothing, yet delivers a massive impact. Most drivers have never heard of it, and that is not because it does not work, but because it works too well in an industry where cooling system problems generate over $40 billion every year, where coolant flushes every 2 years at $150 per visit, along with radiator replacements, water pump failures, and gasket repairs, all depend on the same slow internal corrosion continuing exactly as expected, making a $2 solution that prevents that damage permanently. Something that does not fit into a system built around recurring maintenance and repeat repairs. To understand why this liquid is so effective, it helps to go back to a major turning point in automotive engineering, when manufacturers shifted from cast iron engines to aluminum blocks and cylinder heads, choosing aluminum for its lighter weight, better heat dissipation, and improved efficiency, but also introducing a critical weakness because, unlike cast iron, aluminum reacts internally with coolant under high temperatures, triggering a process known as electrochemical corrosion. Inside every cooling system, different metals exist together, including aluminum, steel, copper, and iron. And when these metals interact with coolant at operating temperatures, tiny electrical currents form between them, creating a galvanic reaction that slowly eats away at aluminum surfaces from within, forming microscopic pits, weakening structural integrity, and eventually leading to leaks, overheating, and component failure. And while this damage becomes noticeable in many vehicles after tens of thousands of miles, in some regions it is almost completely absent. The difference comes down to a compound known as sodium silicate, a solution of silicon dioxide in water, a substance with a long history of durability and resistance to chemical breakdown. And what makes it unique is that it does not simply sit on the surface like traditional additives, but reacts with the natural oxide layer already present on aluminum, forming a bonded, glass-like barrier that becomes part of the metal itself, creating a protective shield that is chemically stable, heat-resistant, and capable of stopping electrochemical corrosion before it can even begin. This protective layer does not dissolve in coolant, does not break down under high temperatures, does not wear away with normal engine operation, allowing it to provide long-term protection that extends far beyond typical maintenance cycles, which is why engines treated with this compound often maintain their internal integrity for significantly longer periods, compared to those relying only on standard coolant formulations. Interestingly, many commercial coolant additives available in stores today already contain sodium silicate as a primary ingredient, but in diluted forms, repackaged and sold for $12 to $25, meaning the core chemistry has never changed. Only the concentration and pricing structure have. And while the labels may suggest advanced formulas or proprietary blends, the active component remains essentially the same compound identified decades ago. Scientific studies comparing standard coolant systems with those treated using higher concentrations of sodium silicate have demonstrated significant reductions in aluminum corrosion, with dramatically less surface pitting and wear over extended operation, confirming what some mechanics and fleet operators have already experienced in real-world conditions, where vehicles treated with this compound continue running for hundreds of thousands of kilometers without major cooling system failures. In practical application, using it is straightforward, requiring only a measured amount added to the coolant reservoir when the engine is completely cold, allowing the solution to circulate as the engine reaches operating temperature, during which it begins forming its protective layer across internal aluminum surfaces. And once this layer is established, it remains intact, even through coolant changes and repeated heating cycles. The process does not require specialized tools, complex procedures, or expensive equipment, making it accessible to anyone who understands how to safely access their coolant system. And the time required is minimal compared to the long-term benefits it provides, especially when compared to the repeated cost and inconvenience of ongoing maintenance services. When looking at the numbers, the contrast becomes even more striking because a single coolant flush costs $150 and is recommended every 2 years, while major repairs, such as water pump replacements and head gasket failures, can cost significantly more, adding up over time to thousands in maintenance expenses, all of which are tied to the same underlying issue of internal corrosion that continues unchecked in most vehicles. By comparison, a one-time addition of a $2 compound that actively prevents that corrosion changes the entire equation, shifting the focus from reactive maintenance to proactive protection, reducing the likelihood of failures before they begin rather than addressing them after damage has already occurred. This difference highlights a broader pattern in how automotive maintenance is often approached, where solutions that reduce long-term problems are not always emphasized as strongly as those that fit into recurring service models. And it raises questions about how widely certain knowledge is shared, especially when it has the potential to disrupt established practices. So the reality is that some of the most effective solutions are not the most visible, not because they lack evidence, but because they eliminate the need for repeated intervention. And once a system is protected at a fundamental level, the cycle of wear and repair changes dramatically, reducing both cost and risk over time. Understanding this shifts the way people think about engine care, moving away from the idea that certain failures are simply unavoidable and toward the realization that many of them are preventable with the right approach, especially when the solution is as simple, affordable, and quick to apply as this one. It also changes how maintenance decisions are made, encouraging a closer look at what actually causes long-term damage versus what only addresses symptoms temporarily, and recognizing that preventing corrosion at the molecular level has a far greater impact than repeatedly flushing and replacing fluids without addressing the underlying chemical reactions taking place inside the engine. In the end, something as small as a $2 liquid demonstrates how a simple change can have a massive effect on the lifespan of a complex machine, turning what is often seen as inevitable wear into something that can be significantly reduced, extending the life of components, improving reliability, and minimizing the need for costly repairs. And once that perspective shifts, it becomes clear that the real value is not just in the cost of the solution, but in the long-term impact it has on performance, durability, and overall ownership experience, proving that sometimes the most powerful upgrades are not the most expensive ones, but the ones that work quietly in the background, protecting what matters most without ever drawing attention to themselves.